Hey everyone, in this video we will understand how we can implement LRU, that is least recently used page replacement algorithm, with the help of C program. So in the previous video we have already discussed what is LRU and how this LRU page replacement algorithm work with the help of example. So if you have not watched that video, please watch that video in the operating system playlist. So you can find full playlist of the operating system on my channel. You can find various topics of the operating system and various C programs. Okay. And along with that, I have made several videos on the computer science topics. You can watch them on my channel. So if you have not subscribed the channel, please subscribe my channel and press the bell icon for further notification of the videos. So let's start with our implementation of the least recently used algorithm. In the previous video, when we discussed the least recently used algorithm with the help of this example, we saw that we will be given a reference string, okay, which will consist of number of pages, okay, which are accessed by the CPU at different point of time, and the number of frames which are allocated to this process, okay, they are given. Let's say we are given 3, okay. So we saw when we applied the LRU algorithm, then for the first time 7 was accessed, so we placed the 7 in one of the available free frame, okay. So initially all the frame were available, so we placed 7 here. Then we saw that 0 is also not present already, okay, in these frames, okay. So it will generate page fault again. 7 generates page fault, 0 will generate page fault, and then we place this 0 in one of the available frame, okay, because we already have the available frame. Then 1 is also not present, so 1 will generate the page fault, and we place 1 here. So my frame has 701. Now when 2 came, my frame was full, so I have to apply the LRU replacement algorithm, okay. So LRU says, okay, if you are, let's say, here, then see in the past, okay. So it says whatever page was used very least number of time in the recent past, that page should be replaced. So according to this, let's say this is accessed at 0 time, this is accessed at 1 at time, this is accessed at second time, or this is accessed at, let's say, third time, that is it is accessed at 3 p.m. okay. So this way I have put the timing, or I have associated the timing with each of the page, okay. So if you see in the past, out of 701, this 7 was accessed at 0 time, okay. So this is the page which is used very least number of time in the recent past. So 7 was replaced and 2 came here, okay. When 0 was accessed, 0 was already present in 201, right? So here 0 was present, so it will not generate page fault, okay. So it was accessed at 4 p.m. let's say. Now 3 was accessed at 5 p.m. So 3 is not present already. We have only 201. So we have to apply the LRU page replacement algorithm so that we can put 3 inside these frame, okay. So any one page should be replaced. So which page out of 201 should be replaced? So again we are at here. So we will see in the past, okay, out of 201, we will see the timing associated with them, okay. So we will see which page has the least timing associated with that. So 2 has 3, 0 has 4, and 1 has 2, okay. That is 1 was accessed, you can say at 2 p.m. okay, but this 2 is accessed at just now at 3 p.m. 0 is accessed just now at 4 p.m. okay. So you can say the priority of this 1 is getting decreased, right? You can say this is used very least number of time in the recent past, okay. So you can say 1 has to be replaced. So 1 was replaced and 3 was put here, okay. But if you saw in the FIFO, that is first in first out page replacement algorithm, according to that, when 3 came, okay, which page was replaced? So according to that, actually 0 was replaced, okay. So in that you saw ki there was a circular movement actually. So when 701 was there and you asked ki, okay, which page should be replaced when 2 came, you said 7. Then when 0 came, because it was not generating page fault, so no issue. When 3 came, you said 0 should be replaced, because out of 701, because out of 201, 0 is the oldest page, okay. So 0 should be replaced according to FIFO. But when we talk about the LRU, then it says, okay, just see in the past, and whichever page is used very least number of time in the recent past, it should be you can say replaced. So 1 was replaced, 0 was accessed just now at 4 p.m. Okay, so we will not see this time, okay, that it was accessed at 1 p.m. so it should be replaced. No, this time is updated to 4. Okay, so it has become newer page. Okay, it has been updated newly in the recent past. Okay, so it will not be replaced. Okay, so this way its priority, you can say, it getting increased. Okay, as soon as the page is getting, you can say, accessed, its timing is getting updated, and that is the key point in the LRU. Okay, that is the only key point in the LRU if you compare with the FIFO. Okay, and that timing thing we will use in our implementation of this algorithm. Okay, so you can see, let's say when we again came for 0, 0 is not generating phase fault. So now when 4 came, we saw, okay, out of 203 which should be replaced. So we saw, okay, time of 203, so it is 0, that is at 6 p.m. it was accessed, 3 was accessed at 5, and 2 was accessed at 3. So which time is minimum? So this is 3 and this is your 6. Okay, so remaining is 3, this is 5. So 2 is the minimum time. Okay, that means if you go in this direction, 2 is used very much before time. Okay, at 3 p.m. only. After that it was not accessed. Okay, the 2 should be replaced. Okay, so the minimum time should be searched. The page with the minimum time associated with it in the recent past, it should be replaced. Okay, so that's why we replaced 2 and we put 4. Okay, and so on. We continued, and finally we found that LRU was giving us 12 number of page faults. Okay, for this entire string. Okay, so now for our example, what we will do, we will take only this much of part. Okay, for our further examples. Okay, so that it is easy to apply the LRU on this small string. Okay, so let's see. So basically for this much part of the reference string, we get how many page fault? 1, 2, 3, 4 and 5, 6, 7, 8. Okay, total 8 page fault. And you can say 1 and 2, these were total number of page hits. So page hits are 2 and page faults will be 8 for this much part of the reference string. Okay, so what will be the input and output for our C program for this LRU? Basically we have to first ask the user about how many pages you want to enter. Okay, so that will be the n number of pages, and then we will create a array, that is reference string array of size n. Okay, so it will consist of, you can say, several pages, right? Then we will ask the user about the number of frames which you want to allocate to this process. So we want to allocate, let's say, number of frames. Okay, let's say 3. Okay, the number of frame variable will be storing this 3, and we will create a frame array of that much size so that the frame can store those pages. Okay, so this will be like, you can say, main memory. Okay, or you can say 3 frames inside the main memory. Okay, so we will create a reference string, we will create a frame of these sizes, right? After that we will get the output, and we have to print total number of page faults generated after the CPU access these different, or you can say these pages. We have to print the page miss ratio or the page fault ratio or page hit ratio. Okay, these 3 things we have to print, and out of which this is the key thing that we have to necessarily print. Okay, so page fault ratio or page miss ratio is simple. Out of n, you can say n pages, how many times you got page fault? So number of page fault divided by n. This is the page miss or page fault ratio. And what is, you can say, page hit ratio? It is out of n times, how many times you got the page hit. That is how many times you found the page already in the frames. Okay, that is the page hit ratio. So if you are given page fault and you are given n, you can find the page hits via n minus page faults. Okay, so let's say for our example, let's say we got how many page faults? We got 8, and the length, total length of the reference string was, it was total 10. Okay, so out of 10, 8 were page fault, so total page hits were 2. So 2 upon, you can say, 10, it will be the page hit ratio, that is 0.2. Okay, and same way we can find the 8 upon 10, this will be your page fault or miss ratio. Okay, so in between this, between the input and output, we have to apply the LRU algorithm, so that by using input we can get the output. So before proceeding, let me show you the output, that is how the output will look like if we run the program of the LRU. Okay, I'll not show you the code first. I'll just show you the output, that how my output will look like. Okay, so this is the output window of our C program for the implementation of the LRU page replacement algorithm. So first we will be asked how many number of pages we want to enter. Okay, so we want to enter how many pages? We want to enter 10 pages, right? And now we have to enter the different pages or the pages in the reference string. Okay, the pages can be like same or different also. Okay, so I will enter 7 0, okay, 1, and the rest of the string I will enter. So I entered the reference string. Okay, these 10 pages I entered. Now it is asking me enter the total number of frames that we want to allocate to this process. Okay, so let's say I enter 3 number of pages. Okay, so we saw here we got the output. The number of total page faults are 8. Page fault ratio, as we saw, 0.80, and hit ratio is 0.20. Okay, so that means page fault ratio you can say 80%, and page hit ratio is 20%. Okay, 20% of the time we found the page already in the main memory or in the frames. Okay, and 80% we were not able to find. Okay, and after giving the input, what is that? Okay, so this is the, you can say, the different contents inside the frames, inside the 3 frames. Okay, at different point of time. So initially we put 7. Okay, so it is 7. Now what is this -1 -1? So actually initially we will put everything inside the frames as -1. Okay, -1 is like an invalid page number stored inside the frame. Okay, we'll initialize with -1 -1. Okay, so when 0 came next time, so it is 7 0. Okay, and -1 is the next like you can say third content. When 1 came, then it is 7 0 1. Okay, and accordingly the content of the frame array will change, okay, at different point of time. Lastly, when all the pages, okay, they are referenced, the finally we have the 432 inside the frame array. Okay, and these are the then page faults, page ratio, and page hit ratio. Okay, so printing these you can say content at different point of time, it is optional. Okay, you can just print it for readability, but main thing is you have to print the page fault. Okay, and accordingly you have to find the page fault ratio and the page hit ratio. Okay, so this is the simple output that we will get after we run the program. Okay, so now let's understand the code things step by step. Okay, and how we will implement or how we will approach this LRU program. Okay, let's first understand the concept of the last access time in the LRU. So basically when we apply the LRU algorithm on this reference string, we put 7 here. Okay, then we put 0, then we put 1. Okay, now after this every frame is like occupied, right? So when we come at 2, okay, now all the frames are occupied, so we have to apply the LRU. Okay, so we saw that we have to see in the recent past whichever page is used least number of times, that page should be replaced. So 2 says, okay, just see 701, and 7 was accessed, okay, very much before 01. Okay, so it was accessed as 0 p.m. okay, very early in the recent past. Okay, but 0 and 1 they are accessed you can say just now. Okay, so 7 should be replaced, so you replace this 2. Okay, and then we come to 0, it will not generate page fault because it is already present. But when we came 3, so 3 will generate page fault. So which page should be replaced? So because the time of the 0 has been updated, now it is accessed at 4 p.m. Okay, so out of 201, 0 will not be replaced. Then we saw for 2 and 1, so the time of 2 access is 3. Okay, and 1 was accessed as 2. Okay, so out of 2 3 4, which is minimum? 2 is minimum, this time is minimum. Okay, so we saw, okay, when 3 came, which should be replaced? The page number 1 should be replaced. Okay, this should be replaced, and so on. Okay, so here the main thing is whenever you encounter a page, you have to update its, you can say, last access time, right? So the 0 was lastly accessed at 4 p.m. okay, till this place. Okay, but if you do not update the access time of 0, okay, you say, okay, 0 was accessed at 1, then it was accessed at 2, it was accessed at 3. When 3 will come, okay, you will say, okay, 0 was accessed at 1 p.m, 0 should be replaced if you want to put 3. But it is not the case with the LRU. So in LRU you have to update the time always. Okay, that means you can somehow, let's say, create a map. Okay, map in which, let's say, you have page numbers, okay, and you have the, you can say, time access, or you can say time of access, or last time of access. So page number 7, okay, then 0 was accessed, then 1. It was accessed 0, 1, 2, okay. Then 2 was accessed at 3, okay. So as soon as we encounter a new page, or you can say previously encountered page, we will update its last time of access. Now when we came here now, then 0 was accessed, right? So its time will be updated to 4, okay. Why? Because when we will come to 3 now, then we will see, okay, out of you can say 201, whatever time is minimum, you have to replace that. So out of you can say 201, okay, this time, which is the least, the time of 1 is least, okay. So we'll replace this, okay. But if we do not update this, okay, we keep this as 1 only, okay, then out of 201, if we see the time 1 2 3, this is minimum, then 0 will be replaced, okay. So we do not have to do this thing, okay. So main thing is, whenever a page is encountered, whenever IF page is encountered, just update this last time of access, okay. And then find the minimum, or you can say find the page with the minimum last time of access, okay. Whichever page has minimum last time of access, that page should be replaced, or that page should be selected as the victim page, okay, by the LRU algorithm, okay. So out of, you can say 0 1 2, okay, 0 1 2, this page number 1 was selected as victim page, okay, so that we can put 3, okay. So this way we have to update the time each and every time, okay. So now let's proceed forward. So basically, as I told you, we have to create a map in which for each page we have to store the, you can say, last time of access of that page, okay. So basically, as you know, LRU is related to your paging technique. That is, whenever your frames are full, then we have to apply the page replacement algorithm, okay. So LRU was used there, okay. And you know that in paging technique we have a table that we frequently use, that is page table. The page table give you a mapping between the page number and the frame number, okay. That in which of the frame number, or you can say in which of the frame, your particular page that is referenced by your CPU in the reference frame, is it actually stored, okay. Where it is actually stored, a particular page is stored at which frame number, that thing or that information is given by page table. But you know, there are many other information that are given by the page table also, okay. Page table basically also give us the information whether a particular page is present inside any of the frame or not, okay. Means, let's say we come to 1 and I want to ask whether 1 is present in any of the frame or not. So valid and invalid bit, you can say this bit, okay, this bit will be telling me, okay, this information. So basically, when the computer starts, then the page table associated with this process, okay, it will be initialized to false, okay. Everything will be false. The last access time, I have, you can say, stored a third column in which I will store the access time, or you can say last access time, when a particular page was accessed lastly, okay. So that this is the thing that I was talking about, okay. We can just store inside the page table, okay. So page table, I do not have to go into the, like, you can say, system programming, or I have to do some changes in the kernel data structure. No, I am not doing that thing, okay. Basically, I will create this mapping table in my C program, okay, in which I will, like, having the facility to store frame number, valid bit, last access time for each of the entry, okay. So let's say we have a fixed size table and we will store these entries for each of the page number, okay. So basically, how we can create this table or the mapping table in our program. So let's see how. So here you can see this is my C program for the implementation of the LRU. So basically, for the page table, I have created a template, okay, or you can say I have made a blueprint using the structure. So my structure name is struct page table, and inside this I have stored frame number, okay, last time of access of that page, and the valid bit, okay, valid or invalid bit, you can say. So valid bit can be 0 or 1, or you can say true, false, okay. So that's why I have taken a bool type variable for boolean, and rest of the things are integer, okay. Now how many entries we can store inside the page table, okay. So as we saw that we can store, let's say 7 page number or 8 page numbers inside the page table. Okay, so that means I have to create a, you can say, array. Okay, I have to create a array so that I can store the various entries. Okay, so basically here we have stored the entries of the total 8 pages 0 to 7. Okay, and in each page, okay, against each page we have 3 things. Okay, so you can say this is, you can say, one of the box of the structure, this is the another box of the structure, this is the another box of the structure. Okay, so I can just say, okay, just create struct, then page table. Okay, then create, let's say, a variable pt of some size. Okay, so you can take any size. Okay, let's say you take some fixed size, let's say 50. Okay, that means you can have the entries from 0 to 49, or you can take a bigger size also. Okay, so this is up to you that how much size you want to take for the page table. Or one way is that, let's say, the maximum reference page inside this reference string, let's say, is 20. Okay, so that means the page table can have, you can say, maximum entry from 0 to, you can say, let's say 20. So you can create a page table of size, you can say 0 to 20 means 21 entries, right? So you can create a page table of 21 entries. Okay, so you find the maximum from the reference string and you take that size also. Okay, that is also okay, and you can take a bigger size also for the page table. It is up to you. Okay, so basically I have created a, you can say, array of structure. Okay, so page table is of size 50, and inside each of the 50 entries against each of the page, I have stored 0 for the valid bit. Okay, that means I am storing invalid. Okay, that means for each of the page I am saying that page is not initially present inside any of the frame. Okay, that's why valid bit is 0. Okay, so this way I have created this mapping table. Okay, so now let's start from the main function and see. First I have asked the total number of pages, okay, which is stored inside n, and then I have created an array of that much of size, okay, which has the name reference string, and this reference string will store my pages. Okay, so inside the for loop I have asked for the those pages inside the reference string, okay, from I equal to 0 to n. After that, I asked the total number of frames that we want to give to this process. Those are denoted by number of frames. Okay, let's say in our example, we gave 3 number of frames. After that, we created an array of size number of frames. Okay, the name of the array is frame. Okay, so the frame array will store my total pages which CPU is asking. Okay, and initially, what I have done, I have initialized everything inside this frame as -1, okay, using the mem set, or you can take a for loop also, as we have used for the page table initialization, right? Okay, so these are the inputs. Okay, so after this, if you see down, I have printed the content inside the frame array at different point of time. So basically from this for loop, okay, our main code starts here. We are implementing the LRU basically. Okay, so from for, okay, we come here. Okay, then we come down. Okay, and here my for loop ends. Okay, so after for loop I'm printing total number of page faults, hit ratio, and the miss ratio. Okay, so let's see the main code. Okay, now here, that how this for loop is working and what is the meaning of this for loop basically. Okay, and how we will apply the LRU and where we are actually applying the LRU. Okay, so before proceeding, let me tell you that this code is actually similar to the FIFO. Okay, that is the FIFO program that we saw in the previous video. Okay, in that program we saw that we use the page table. Okay, we use the valid bit. Okay, we use the many of the things, right? So you will see that only 2% code change will be there in the LRU implementation, okay, or in this program. Okay, 98% you can say the program will be similar to what we have seen in the FIFO page replacement. Okay, so if you have seen that video, it will be very easy to understand this, and if you have not seen that video, okay, then also it will be like no problem, but it is like recommended to watch that video also. Okay, so that you can get a good grasp over the LRU implementation. Okay, so let's see, I'll tell you everything here also. Okay, so let's first understand the overview of this for loop, that how this for loop is working before going into the nitty-gritty of the, or you can say, technicality of this code. Okay, so before going to the you can say technicality, let me tell you, let's say this is the page table. So what we will do, let's say 7 was accessed. Okay, so we will first search that whether 7 is present inside the frame array or not. Okay, but basically how we will do that, we will not apply any linear search on this frame array. Okay, to ask, okay, frame, let's say 7 page is present inside any of the frame or not. Okay, we will not do this thing. We will directly go to the page table. Okay, and we will directly go to the 7. Okay, it is like a array, or you can say, okay, so we will directly go to this 7th page and we will check its valid bit. Okay, so if valid bit is 0, that means 7th page is not present inside any of the frame. Okay, but if it is 1, then means we will check the frame number and we will see, okay, that particular frame number contains my 7th page. Okay, so initially 7th will generate page fault, so because valid bit is 0. So what I will do, I will find the free frame, right? I will find the free frame and then I'll put here. Okay, so I'll put, okay, 7 can be put here. Okay, and then what I have to do, I have to actually update the page table because 7 was already 7, because 7 has come inside here. Okay, in the 0th frame. So I will say valid bit is 1, 7 has come in 0th frame, and then I have to update its last time of access. Basically what I will do, index of this will be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, basically I will use these indexes as the time of access only. Okay, we will use these indexes as the counter, you can say. Okay, so I will put this 0. Okay, so 7 page was access at 0 time. Okay, now 0 will come, so I'll go here and 0 is not present because his valid bit is, you can say, 0. So I'll put inside any of the free frame, right? So I'll see, okay, 1 can be put here, so I'll put this 0 here. Okay, in the frame number 1. So now for this 0th page, I'll update this. Okay, and I'll update this frame number. 0th page is now in frame 1 and its time of access is 1. The same thing I will do for 1. Okay, 1 is not present because its bit is 0, so I'll put 1 inside any free frame here in the second frame. So I'll say, okay, now you are 1, I'll put you into the second frame. Okay, so I'll update the page table so that next time if you come for the 1, you will directly say, okay, this bit is 1, that means it is present in one of the frame, that is frame number 2. Now for 1, the time of access is 2. Now basically when you come for 2, 2 is not present. The same way what you will do, out of here you have to apply the LRE. Okay, so basically you will find the time of all the 3, it is 0. Okay, it is minimum out of 701, out of 701, 701, this is 1, 2 and this is 0, so 0 is minimum. Okay, so for the page 7 I'll do this thing, that is here I'll apply 2. Okay, but as I told you here, when you are putting 2 here at 7, you have to update the table 2 times. Why? Because as 7 is going out of this frame, okay, 7 will not be present anymore inside this 0th frame, so I have to invalidate this entry for the 7th page. That is, I'll say you now become 0. Okay, because you are not anymore present inside the frame. Okay, so I'll say okay, and along with that, if I want to change the frame number, I can set any invalid frame number. Okay, I can just set it as -1. Okay, or I can leave this as such also. Okay, there is no harm. Okay, after this updation, I will put 2 here actually, and then next time I will update this entry for 2 also. That is, I have to update for 2. Okay, what I have to update, I will say, okay, 2 has come inside 0th frame, so you will become now 1, and 2 has access at 3rd time. Okay, or at 3 p.m. Okay, so we have to update the entry for 7, that the page that is going to be replaced, the page that is coming, for that I have to update the entry. Okay, so for removed page, this bit will become 0. For the newer page, this bit will become 1, and frame number and time of access should be updated. Okay, so let's see in the code how we will do this thing. Okay, so basically this is our for loop. Okay, and this for loop is going to end here. Okay, and this is our else. Okay, this is our simple you can say if. Okay, and this outer if is ending here. Okay, and after this all complete for loop, we are printing the page fault and the other thing. Okay, and this is my page table and this is my frame array. Okay, so basically for each of the page, for the ith page from 0 to this you can say last nth page. Okay, what basically we are doing, we are saying, okay, 7, this ith page is present inside the frame array or not. okay, and then that we will check with the help of page table. So we saw, okay, 7 is, if let's say not present in your frame array, then we will say there is a page fault. We'll increase the page fault, and then we have two you can say options. If a page is not already present inside the frame array, then basically what we have to do, it may happen that your frames can have empty spaces, so that we can put this 7 inside any of the frame. Or it may happen that when we encounter that 7 is not present here, okay, so it may happen that some other pages have occupied all the 3 frames, there is no space left, then we have to apply the LRU first, so that we can make the room for another frame, another page. Okay, so if frame array has vacant frame, then do this thing. If not, frame are full, then apply the LRU and do this thing. Okay, so either if or else will work. Then go to the next ith page, check if it is in the you can say frame array or not. Okay, that means with the help of page table we'll get to know. If not, increase page fault, check frame are available, then do this thing. Not, then apply the LRU and put that page. Okay, and if let's say for any of the ith page we saw, if page is already present, then this if will be, you can say, false. Then we will come here and we will do nothing. Okay, if page is already present, then do not increase page fault and do nothing, right? So basically this way, okay, we will keep on increasing page fault as and when there is a page fault. Okay, so let's see how we will work upon this reference string. Okay, so basically first we will come for I equal to 0, that is 7. Okay, we'll search 7 is present inside the frame array, so we'll directly go to the page table actually. So here we will needing page table. So from page table we'll get to know that all the valid bit will actually be initially 0, right? So this is 0. Okay, so I'll say, okay, this 7 is not present, okay, in any of the frame, right? Because if it is 1, then only we can say, okay, my 7 will be present. Okay, so I'll say, okay, not present, so increase the page fault will become 1. Then I will check whether my frame has some space or not. Okay, so initially frame array will be empty, so I will come to if, then I will put that page. Okay, so I'll put here, and then I'll update the page table. Okay, so page table will be updated for 7 as what I will do in update page table, I will valid bit will be set to 1, and the frame it will be updated to 0. Okay, so basically after this I'll leave, and then I will come for the next page. Okay, for 0th page. Okay, so basically again I'll check 0 is present in page frame array or not with help of page table. So if bit is 0, I'll say no. So I'll increase the page fault. Okay, now I'll check frame has empty space or not. Yes, so I'll put ith page into the vacant frame. Okay, so basically now I'll put this 0 here. Okay, but the thing is there should be some, you can say, pointer, or you can say there should be some particular person who should be pointing to this 0, then 1, then 2. Okay, so that I can say, okay, put my this 7 inside frame of 0, put my 0 inside frame of 1, and so on. Okay, so basically I will use a current named variable inside my program. Okay, so here I will do that thing. Okay, so I'll put you can say frame current equal to my 7, frame current equal to 0. Okay, so current will initially start from 0, and then it will keep on updating to 0, then 1, then 2, and so on. Okay, so basically after putting 0 at this current position, I will update the page table. Okay, I'll put 1 here and the frame number 1 here. Okay, and basically I forgot to update the time of access, right? So in the previous case for 7, my time of access was 0. For this 0th page, time of access is 1. Okay, now basically I will do here update current will be updated to here. Okay, so this way my current has become 2. So next time when 1 will come, it will be placed here. Okay, I think you can do this by yourself. Okay, 1 will not be present, frame page fault will be 3, vacant frame was there, 1 I update here, so 1th I will become 1, it will become 2, and this 1 is accessed at 2 p.m. right? Now after this, current will become what? So current will become 3, but actually I have to do something so that next time this current should be used in such a way that frame of 3 position cannot be accessed because it is an invalid position, right? So basically I will do something here, okay, and let's see how. So basically next time when we will come for 2 na, 2 is not present, I'll update here, but frame is not empty, so I'll come to else, okay. So basically for 701 I will come into the if, but for the next of the pages I will always come for here, okay, in the else part, okay. This will be encountered into the else part only. So now I will apply the LRU. I will find the pre-frame, okay, sorry, I will try to find the victim page that is going to be replaced, okay, and then I'll mark that page, okay, that page, let's say I'll say, okay, out of 701, okay, which page has the minimum page? 7. So 7 should be replaced, okay. So I will replace this 7 and then I'll put 2 here, okay, and then I'll update table entries 2 times, okay. So basically this we will do here, okay, and accordingly we'll go for the 0, okay. But here one thing you have to notice, when you come for 2 now, you have to like update the page table for 7 and 2, but please take care that for 2 you have to update in the page table one very important thing, we have to update the time of access. In FIFO we were just updating valid bit and frame number for 2 this new page, but for here we have to update this also. So 2 was accessed at 3, okay, because this is the main key point in the LRU, okay. So all the 3 things, okay, this will be changed, right? Okay, so this way we will go on and finally we will print the page fault, okay. So let's see with the help of code how we will work out, okay. So this is my for loop, okay, and we will understand this, okay, with the help of this code, okay. So basically if you see for my 7, okay, for I equal to 0, I'll say if my page is present or not, okay. So here you can see I have created a function, okay, is page present, and this is basically taking a, you can say, page table, okay, page table and the page number that I want to actually search for, okay, reference string. So reference string I is 7, okay. So array and the 7 will be passed. So is page present will return true or false, okay. So if you see up here, you can see page table and 7 is passed. So if page table 7 dot valid is 1, so page table 7 dot valid, that is this, it is 1, then I will say return true, otherwise false. So for 7 this bit is actually not 1, it is 0, so it will actually return false. That means my 7th page is not present inside the main memory or the frames, okay. So I'll come here basically, and because I have to go inside, okay, so I am changing it to true, okay, by not. So I will come here and for 7th page I'll increase the page fault, okay. So my page fault has got increased, okay, so page fault has become 1. Now basically here you can see I have taken a variable current, okay. So current is basically, as I told you previously, current initially it will be 0, okay. So if you want to see in the code, okay, in the main function, current is basically 0. So now current 0 is less than number of frames, okay. So this is basically checking the capacity, okay. If my current is like full, okay, it is like let's say it is 2, okay, so it will run for 0 less than 1, sorry, 0 less than 3, 1 less than 3, 2 less than 3, okay. So it will basically check the capacity if any of the frame is empty or not, okay. So this variable is helping me to do that thing. So 0 is less than 3, okay. So you can say, okay, my frame array is like basically has some empty frames, okay, because current is here only, okay. So all the rest of the frame will be empty. Now basically what I am doing, I am saying, okay, if frame is available, directly put reference string inside the frame of current, that is frame of 0, okay. So frame of 0 will basically now contain what, my this 7, right. Now after that what I am doing, I am just printing the print frame content, okay. So initially everything was -1, you can say -1, -1, -1. So my content will be like 7 -1 -1 with the help of this print frame content, okay. I just want to print this updated frame array. So if you see, I have just used a for loop to print the content of the frame, okay. I equal to 0 to number of frame of I, that is 7 -1 -1, right. So this for loop is just printing, okay. you can use this print frame content, or you can just leave it. Okay, main thing is after putting the reference string inside the frame, you have to update the page table, right? Now here it is important to know what we are passing inside the page table. Okay, so basically this update page table is a function that is accepting 4 things. So because this page table, you can say update page table, I am writing upt, it is accepting 4 things. What is this? Is page table, then reference string I. Okay, for the page number for which I have to update the entry. So I have to update the entry for basically this ith page, right? For this ith page I am passing 7. After that I am passing again the current. Current is basically the frame, okay, for this newer page. Okay, so 7 is put inside 0th frame. I am passing this current. Okay, this is the frame number, right, for the 7th page that I have to put into inside this page table. Then I am passing 1. 1 is the this bit, valid bit. I have to set this valid bit to 1, right? For 7 I have to put this 1. Okay, so I am actually passing 1. Now next thing that I am passing in this LRU is the time of access. So here you can see I am passing I. For the ith page, its index I is passed as the time of access. Okay, that I have told you. So 0 will pass. So in the LRU, we are passing actually 5 entries, not 4 actually. But in the FIFO, we saw we are just passing these things only, right? Because at that time, your time of access was as if not needed. Okay, so after we pass these things, update page table will do the necessary updation. So if you see above, here you can see update page table. So this is the update page table. Basically it is accepting each and everything. Okay, here you can see, right, in the header. So you can see the valid bit will be set to status. Okay, so status is basically, you can see the second last, this 1. Okay, so 1, so it will be set to here, right? Now I will check. Okay, if it is 1, that means these entries should be updated. So I'm saying, okay, just update the entry. If the status is 1, just update the last time of access. Okay, the last time of access was coming as this 0, right? 0. And the frame number will be updated to what? This is the frame number for 7, it is 0, right? So I'm just updating this entry whenever the status bit is 1. Okay, otherwise I'm not updating. I'll see later. Okay, that why I have put this if condition. Okay, so I have set all the 3 things valid. If it is 1, update this and this also. Okay, now after updating, just go to the next page, right? So if you see, after doing all these things, just go to the next page, but before that just increase the current. So current will now point to 1, right? Current will point to 1. Okay, now I'll tell you this thing. So if current is number of frames, if current become equal to number of frames are 3. So when current will become 3 now, after updation, then you have to do this thing. But what is that thing? I'll tell you later. Okay, so for this thing, 7th we are done. Now if you see down, we will just go to up, right? So for the next ith page, that is for this 0 will come, will say if my 0 is present. Okay, so my valid bit will be checked by is page present method. So for 0, I'll say this is 0. So this is page present will return me false. No, it is not present. By not, I'll come here and I'll say it is 2 now. So now basically I'll say current is less than number of frame. Yes or no? Yes, 1 is less than number of frame. Basically, if you see here, I have used a flag variable. Okay, I'll tell you later again why I'm using flag, but basically flag is initially false. Okay, so if you see above now, I have taken a flag variable, flag false, which is basically false, right? The flag is false here, and this is also true. So I'll come here and I'll put reference string inside the frame current. Why? Because my array is actually free. Frame is free. This is told by current less than number of frame. So I'll put this 0 where? Inside the current index. So I'll put 0 here. Sorry, 0 here. I'll put print the frame content. Okay, update the page table. Okay, so what will be passed now? So I'll pass pt. I'll pass what you can say reference string, that is just 0. Okay, and the frame number for 0 is this current, that is this 1. Then I'll pass the valid bit, that is 1. Now I'll pass the time of access. So for 0, I is this, I'll pass this only. So basically for 0, my this entry will be set, frame number will be set to 1. Okay, this you can say last time of access will be set to 1. Okay, so current will become now to 2, so that next time this should be allocated. So this way again it will go for 1, and the same thing will happen for 1. Okay, I think I need not to update it again and again. Okay, so for 1, what will be the thing? 1 will be put here, right? And for this, the table will be updated. So for 1, this will become 1. 1 is accessed as 2, and 1 has been put inside this 2. Okay, so yeah, this is done. Now after this, current will become, you can say 3, right? Current plus 1. But when current is become to number of frame, then you just say flag is equal to true. Okay, flag is equal to true. So how it will help? So if you basically go for the next page, that is this, I equal to 3. This 2 is also not present. I'll increase the page fault. Okay, so basically it was 3, now it is 4. So basically flag is now not false, it is basically true. So I'll say okay, till the point flag was false, go inside, but now it is true. So true equal to false, no, do not go inside. Okay, so basically I'll not check this thing. Okay, the flag is a barrier which will be basically checking the first condition. If it is true, then only you can just go out of this if. Okay, so flag is true, go out of this if. Okay, now basically come to else. So as I told you, else will handle all the cases when frames are full. Okay, now only else will run always and always. Okay, so inside else we came because the frames were full. So the main thing is now what we have to do. So we have to apply the LRU. Okay, LRU, so that we can find the victim page. So how LRU find the victim page? By using this last access time field, right? Whichever has the last access time as minimum, that page should be can say selected. So now I have updated, now I have made a some you can say mistake. For you can say 1. Okay, for you can say this one, the last access time was here 2. Okay, so now here I have made a function search LRU page. Okay, and this will actually search the index of the victim page. Okay, out of 701, let's say 7 is going to be replaced as we saw earlier. So this 0 will be returned by this search LRU page. Okay, so basically it will take the page table, will see frame number of frame, and there is a variable LRU page index. Okay, I'm passing the address. Okay, so basically LRU page index will contain the index, or you can say frame number of that page which is going to be replaced. Okay, so for 7, 0 will come inside LRU page. So I'm passing this by using call by address. Okay, you can just return also. Okay, you can just return and you can save inside LRU page index. Okay, but I am passing by call by reference. Okay, so if you see search LRU page, how it will give me the like desired thing. So if you go here, so page table, frame, number of frames, okay, many things are just actually passed, right? Here you can say LRU page index is a pointer now because address is passed. Now basically if you see here, what we have to do, we have to actually find the minimum between these three you can say times. Okay, so basically what we will do, for I equal to 0 to number of frames, for all these 3 frames, we'll first pick this 7. Okay, that is 0 to index 7, and we'll say okay, the last access time of this 7. Okay, so I is, you can say 0, frame of 0 is 7, so pt of 7. Okay, so it will become pt of frame of 0 means that is 7, pt of 7, its last access time. Okay, I'm just writing last. Okay, so 7th last access time was 0. It is less than your current minimum. So initially my current minimum was very large, int max, so that the first entry should be less than minimum. So let's say int max can be like 9,90,000. Okay, that's a very big value. My last time of access of 7 is 0. 0 will be less than, let's say, 1 lakh. Okay, so I'll say okay, this 0 should be updated inside my minimum, right? Okay, so my minimum will become, you can say 0, and the index of this 7 will become this 0. Okay, it will be saved inside LRU page index. Okay, that is not a big deal. Okay, so you can say I'm writing index simple 0. Now next time again I'll come for 0. and I'll check it's this time this one is less than your minimum. Okay, last minimum was 0. Okay, but it is false, so I'll not update, right? Next time basically I'll come for this one. Okay, so I'll check its uh, last time of access inside page table. It is 2. Now 2 is less than previous minimum. No, it is greater. Okay, so I'll not update anything. And finally I'll come out, and in LRU page index my index number 0, this was present. Okay, because out of everything this 0 is minimum. So my LRU page is selected whose index page is or index number is 0. So I'll go down, and now I will use this LRU page index to be replaced. So here you can see in update page table. Okay, in update page table I'll update that 7 is now being replaced. Okay, so basically what I will pass in this update page table, so I have to update the entry for 7, right? So you can say for 7 I have to set it to 0, right? And I can like set it to frame number to -1. Okay, and I can update this last access time. Okay, so for 7 what I have to do, I have to update this to 0. I can update the frame number to -1 if I need. Okay, otherwise no need also. Okay, you can just put it 0 valid bit. Okay, and last access time should not be touched. Okay, because it is not accessed. Okay, it is going to be replaced. Okay, it should not be touched. So basically if you see, we are passing the page table. Okay, the frame LRU page index. Okay, so frame array is this, LRU page index 0, that is 7. We are passing 7. For 7 we are saying okay, this is the frame number. The third entry is -1. That is, you can update this to -1. Okay, valid bit will be set to 0. Okay, and here I am passing this I for current time it is like 3, but as I said for 7 this time should not be you can say touched. There is no need. But then also I am passing I. Why? Because here in my update page table actually I have taken 5 arguments, so I have to give this 5 argument. I cannot leave it as such, otherwise type compatibility will come. Okay, but I will not use this I. You can see in the here. Okay, so basically I will set valid bit for sure. Okay, so this valid bit will be 0. Now you see I am saying okay, frame number and last access time, that is this and this, they should be touched only when the status bit is going to be valid bit. But now status bit was coming as but status bit that I sent from the main function, it was actually 0. Okay, this bit, the last fourth bit, it is 0. So I should not touch this frame number, last access time, although I passed. Okay, that's why I said these things will not be actually touched. Okay, so now if you come down, okay, actually if you if you remove this status equal to 1 and you update last access time and frame number also, then also it will not be a big deal, it will not make a problem. Okay, but I am doing optimization by using this status equal to 1 condition. Okay, now if you see down, basically inside the else, so if you search for the victim page, then you update the page table for that victim page. Now what you will do, now you can safely remove this 7. Now basically you can safely remove this 7. Okay, by 2. Okay, so here if you see, I'm saying reference string should be saved inside what, frame of LRU page index. LRU page index is telling me at which position my reference string should be placed. Okay, so at this page. Okay, so the LRU page index is having 0, so my frame array will contain now 2. Okay, and then I'll just print frame content and I'll update entry for 2. Okay, so I think you can just do this thing, that for 2 I'm passing these things. Okay, and for 2 I'll come here and I'll say 1 is time of access, 3 will be passed, and what is the frame number for 2, it is 0. Okay, so the frame number was actually this third thing, and if you see in this update page table, I am passing LRU page index at the third thing. Okay, that is, this is the frame number for this 2. Okay, lastly let's proceed for the 0. For 0, if I come here and I will check inside the page table, okay, I'll see it's valid bit, it is already 1. Okay, so my update page table, sorry, is page present function, this function will tell me, okay, it is actually true, not of true, it will be false. So for this 0, I'll just come out of all the if else, I'll not do anything. Okay, I'll come here, but for this 0, I have to update this time to 4, right? Update this access time to 4. So basically after here I am updating this, you can say this is the important thing, this access time, okay, for this reference string ith page. So for this 0, I am saying pt of reference string I, that is pt of 0, that is pt of this 0th page dot last access time, that is this, it should be made I, currently I is 4, so this 1 should be changed to 4. Okay, so 0 did not give me page fault, but access time should be updated. Now go for the next ith page, that is 3. Okay, and for 3 again it is not present, page fault should be increased. Okay, so it will be like 5, and then I'll say flag equal to false, no, flag is equal to true. Okay, so I'll not come here, I'll come here, search the LRU page. Okay, so for 3 basically I have to find the minimum. So for 2, what is the minimum time? Okay, so for 2 basically 3 is the minimum, right? Then I'll, for 0, I'll apply the this search LRU, okay, because it is actually finding the minimum. Okay, so for 0 the time is 4, okay, but 3 is basically less than 4, so minimum is actually 3 only. Okay, that is the index of, you can say, 2 only. And lastly I'll come for 1. So the index, or you can say the access time, is basically 2, okay, for 1. Okay, so this access time 2, it is basically, you can say, 3 is less than 2, no. Okay, the last access time was 3, now currently it is 2. Okay, so basically if you see, okay, in the code you will see the 2 is less than your previous minimum. Okay, this is the last access time of the ith page. Okay, ith page, so 2 is less than 3, my minimum will become 2. Okay, so my minimum will become 2, and index will be, or you can say LRU index will be what? LRU index will be for this 1. Okay, so for 1 my LRU index will be 2. Okay, you can just check the code by yourself. Okay, so minimum will be 2. Okay, sorry, minimum number will be 1 and its index is 2. Okay, so this is the LRU index. Okay, LRU page index will become 2. For 1 I have to update the page table. Okay, so I'm saying okay, just set everything to this 0 and this thing. So basically for this page number 1, I'll update this to 0. Okay, and I'll not touch this. Then I'll put this 3. Okay, this 3 here, and for 3 again I will update this page table, right? So it will basically 1, access time is 5, and this will become 2. Okay, 3 has come inside frame. So this way we are updating everything, right? Okay, so this will go on, and my for loop will end, and after that I'll come out, and then I'll do this number of page fault ratio, and page hit ratio. I think you can do it by yourself now. Okay, the total number of page fault will be printed, and page fault and hit ratio can be like easily calculated. Okay, so let's find the time and space complexity of this question before proceeding this video. Okay, so my time and space complexity will actually be similar to what we have seen for the FIFO in the previous video. So basically this code is running for n times. Okay, for I equal to 0 to n. So my for loop will have like O of n complexity. Okay, and basically what I'm doing, for every page I'm checking whether that is present in frame array or not. Basically I'm checking this page table directly. I'm going to the particular page, and then I'm checking its valid bit. Okay, so it is like O of 1 time. Okay, it will take 1 of time. Okay, it will not checking actually the array. Then I'll just doing this atomic operation, or you can say this you can say single constant time operation. Okay, then I'm checking if my frame array has vacant frame or not. And how I was checking my frame array is vacant or not? Basically, I was just checking okay, if my current is less than number of frames. So basically, this is simple. You can say or one time thing. Okay, I'm not using any function call or something, right? Okay, and then I'm just assigning the page, and then I'm updating the page table. Okay, so updating the one of the entry of the page table is like a one time thing. Okay, inside else again, when I was checking the LRU page now, okay, just check the LRU page. So I was checking the LRU page how? Here in the LRU page selection, what I was doing, so I was saying okay, let's say this is the X page number, this is Y, this is Z. So for X page, I was coming to the X page, and then I was checking its you can say last time of access. Okay, and I was just comparing it with the like last minimum. Then I was coming for the YH page, and I was checking for its you can say last time of access with the previous minimum. The same thing I was doing for the let's say Z page. Okay, so that means for finding the LRU page by method that I made, it was actually running for how many times? The number of frame times. Okay, so it will be basically of time complexity number of frame. Okay, for each of the frame it was just doing constant operation, so it will run for O of number of frame. Then I'll just update the page table. Okay, so it will be of O of 1 and mark the entry. Okay, I was actually updating 2 times, so 2 times page table updation will be like O of 1 O of 1. Okay, so basically this thing will be done for O of n time. So basically if you do the time complexity calculation, it will be O of n. Okay, and this everything is O of 1, that is okay. So either you will do this thing or you will do this thing. Okay, so basically O of n. Okay, so for 1th page, let's say for particular ith page, okay, let's say you come for this. Okay, after the this thing was full, you come for this. Okay, and then you were finding the LRU page. Okay, for ith thing you are first finding the LRU page. Okay, if this complete is full, so O of n multiply O of number of frames. Okay, so this we are doing for the LRU selection, LRU page selection, and this we are doing for the ith page. You can say n number of pages. Okay, this will be my time of complexity. O of you can say O of n into number of frames. Now what will be the space complexity? So my space will be taken by this frame array and the page table. So my space complexity will be equal to the sum of the size of the page table and sum of the you can say size or you can say number of frames. So it has 3 frames, and the let's say size of the page table was 50, so 50 plus 3 something like that. Okay, but it is like a variable thing. Okay, let's say if I you can say it will be like generalized thing, size of page table plus number of frames. Okay, number of frames can be anything, and size of page table, if we let's say just take a very small number, then it will be like equal to O of number of frames only. Okay, so this is the generalized space complexity. Okay, so I hope you have now understood that how this code is working. Okay, so please like and share this video and subscribe the channel and press the bell icon for further notification of the videos. Okay, and do share a comment please, so that I can get a motivation that yes, you are liking these videos, so that I can make further videos on the certain topics or you can say the similar topics. Okay, so see you in the next video. Till then, goodbye.